Hi everybody, today let's look at integration. Integration as the inverse of differentiation. Integration is actually the reverse of differentiation. If I have a function f of x, I differentiate it, I will get f prime of x. This is the first derivative of this function. From here, go here, this is differentiation. You have learned before this one. Okay, from here, go here. This is integration. This is what we are going to learn today. Okay, let me give you two functions. Y equal to 3x squared plus 2x minus 3. And I have another function, looks similar to this, but now, this time I change the constant. Y equal to 3x squared plus 2x plus 10. Okay, let's do the differentiation for these two functions. dy by dx is equal to 2 times 3, you get 6. Copy the x, and the power here you always need to minus 1. 2 minus 1, you get 1, you don't have to write the 1. If you differentiate the 2x, you get 2. Differentiate a constant, you get 0. You don't have to write 0. Okay, how about this one? dy by dx. 2 times 3, you will get 6. Copy the x, and same thing, the power always need to minus 1. 2 minus 1, you get 1. Okay, differentiate 2x, you will get 2. Differentiate a constant, you will get 0. Okay, you will notice that even though these two functions, they are different, but when you find their first derivative, you actually get the same thing. So just now I told you that integration is actually the reverse of differentiation. From here, go here, this is differentiation. From here, go back here is integration. Same thing here. From here, go here, this is differentiation. From here, go back here is integration. So how about if I ask you to integrate this 6x plus 2? Now we have a problem. How do we know we need to write this one or this one, right? We actually don't know which one to be chosen. Okay, to be chosen. So what we need to do is we just integrate this part. Okay, the process of integration is like this. You copy 6, then copy x. The power here you always need to plus 1. Just now from here, go here, we minus 1. Now go backward, we plus 1. 1 plus 1. Okay, whatever you write here, you have to write the same thing for the denominator, 1 plus 1. If you integrate a constant, you just add an x to it. At the back here, we actually don't know. It says negative, we don't know this negative 3, positive 10, or even other constant. It can be 0 as well. So for an indefinite integral, it means that we don't have the lower limit and upper limit. We always write plus c at the back. C stands for the constant. Okay, so this is 6x power 2. This is 2 plus 2x plus 2. This is 3x squared plus 2x plus c. Okay, now we have changed this one. Go back to this. This is integration. Okay, so remember, for an indefinite integral, when we integrate it, always write plus c at the back. Now, let's look at few other examples. Determine the indefinite integral by inversing the differentiation. So the question tells us that dy dx, if you differentiate this one, you get this 3x squared minus 2. Now we know that integration is actually the reverse of differentiation, right? So now the question asks us to differentiate this one, which is this one. We don't have to integrate one by one. We just copy. Because differentiate this, you get this. Integrate this, you get back this. X cubed minus 2x. And remember, for an indefinite integral, after we integrate it, always we write plus c at the back. Okay, now for b, also the same thing here. Differentiate this one, you get this. Differentiate this, you get 20, then parentheses 5x minus 2 root the power of 3. Now the question asks us to integrate this. You will notice that this is exactly the same like this one, right? Differentiate this, you get this. Integrate this, you get back this. Just copy the whole thing, and don't forget this is indefinite integral, which is plus c, right? Plus c at the back. Okay, now let's try other example. Find the first derivative of this one. This is y. So it's actually the question right at this. It means that we want to differentiate this part, this function. Okay, so this is just a revisions for the previous chapters. For differentiations, first thing, when we see the x at the bottom like this, we change the form of, we change the way of writing this. 4x power negative 2. Okay, now we can start to do the differentiation. Negative 2 times 4, you get negative 8. And copy the x. The power here, you always need to minus 1. Okay, then we change back to this form. Now, the question asks us to integrate this. For the differentiation part we have done, we got the answers. Now we go to the second part, which is integrate this. You will notice that this is exactly the same as this one, right? If you differentiate this, you get this. You integrate this one, you go back to this. So you don't have to do the integration process. You just copy this one. 4 over x squared. And don't forget, for indefinite integral, we always write plus c at the back. Let's go to part B. First part, we need to find the first derivative of this function. Okay, first we change the way of writing these functions. It becomes 5, 7 minus 2x raised to the power of negative 3. Okay, I hope that you still remember how do we differentiate this type of functions. Bring the negative 3 go down here, multiply by 5, you get negative 15. And this one you just copy 7 minus 2x parenthesis, and the power here you always need to minus 1, negative 4. And don't forget, we have to differentiate some more inside here. You will get, when you differentiate this, differentiate you get 0, differentiate this one, you get negative 2. Remember to write the negative 2 here. And negative 2 times negative 15, you will get positive 30. 7 minus 2x raised to the power of negative 4. Okay, let's change back to this form. Okay, so this is the final answer. This is the first derivative of this function. Now the second part, the question asks us to integrate this. Let me copy first. You will notice that this is exactly the same as this one. From here, we differentiate it, we get this. And if we integrate this, we get back this. So you don't have to go through the integration process, you just copy straight away. You just copy this whole thing down here. So it's equal to 5, 7 minus 2x raised to the power of 3. And don't forget to write plus c at the back. Okay, let's try one more question. Given y is equal to this, and the first derivative, if you differentiate this one, you get this. Let me copy down first. dy by dx is equal to this, x minus 4 over 2 times square root of x minus 2 raised to the power of 3. So the question asks us to integrate this one. You will notice that this looks similar to this one, right? But not exactly the same. If we differentiate this one, we get this. So from here, we know that if we integrate this, we go back this, right? But the problem is here. The problem here is this is not exactly the same as this one. So how do we do? Okay, the first step, I just copy this whole thing down here first. X minus 4, copy the whole thing, because I need this one to help us to get the the answer for the integration part. But this is actually not correct, right? This is not equal to this. So actually I cannot write like this. So in order to keep these two equal, I want to get rid of this 2 here. How do I get rid of the 2 here? I add a 2 over here. So the 2 and 2, they can actually cancel out each other, then it becomes equal. Okay, so the next step, just copy the 2, integrate this one, we go back this, just copy this whole thing, x over square root of x minus 2. And because this is indefinite integral, don't forget to write plus c at the back. 2x over square root of x minus 2 plus c. Okay, for this video I stop here first. See you next time. Thanks for watching. Bye bye.